There are multiple strategies for ensuring that data processed and generated by an application ends up in an encrypted state on disk. Let's look at a few common scenarios for persisting data in a cloud environment and see how that data is encrypted. In each scenario, we will have some common themes. A key management service will be needed to store and manage encryption keys. Applications and infrastructure will be configured to use a specific encryption key that will be used to encrypt the data. AWS provides a key management service called KMS. KMS is tightly integrated with the AWS services and the AWS SDKs that a developer would be using. Choose to encrypt the data with the application prior to persisting or writing. We will loosely refer to this as client-side encryption. The AWS services can also be configured to handle the underlying encryption activities. We can refer to this broadly as server-side encryption. Let's look at how encryption works when writing data to disk. An application may write data to a file on disk that is in a mounted directory on the local operating system. The underlying volume may be mounted from an EBS volume or an EFS share. The application can obtain a data encryption key from KMS and use it to encrypt the data prior to writing to disk. Once a data encryption key is obtained, developers can choose to use language-native encryption libraries. They can also leverage the AWS SDK to go through the encryption process. The AWS SDK helps by encapsulating many of the steps required to encrypt and store the data. On the infrastructure side, we need to ensure that disk volumes are configured to use KMS encryption so that the entire disk remains encrypted regardless of the fact that the application chooses to encrypt or not. The EC2 service can obtain a data encryption key from KMS. The encryption key is based on a master key that the EBS volume is associated with. The data encryption key is then used by the hypervisor to ensure that all I/O operations result in encrypted data on disk. Write operations will use the key to encrypt and read operations will use the key to decrypt. The hypervisor will make the data available and decrypted to the instance operating system. We will also be writing data to a database table. The same concept we use to write data to disk volumes applies here. The application should encrypt sensitive data prior to storing the record value in the database. Again, on the infrastructure side, we need to ensure that encryption is enabled when provisioning the databases in AWS. When encryption is enabled, services such as DynamoDB and RDS will leverage KMS master keys to ensure that the data is encrypted at rest. Applications will be using cloud storage such as S3 to store data and file objects. When an application is handling highly sensitive data, the code should be designed to encrypt the data object prior to putting it in S3. Because we encrypt the object prior to making the call to write the object, we refer to this as client-side encryption. In the case of the S3 service, the application can also set parameters on the put object call for server-side encryption. This tells the S3 service to handle the encryption for the object that is being stored. We can also configure S3 buckets with default server-side encryption. With default server-side encryption enabled, the S3 service takes care of the encryption of the data on the underlying infrastructure. As a best practice, we want to ensure that S3 server-side encryption is enabled by default for all buckets so that the encryption logic can be encapsulated from the application code. So, client-side or server-side, which one should be used? Let's look at the pros and cons of client-side encryption. The data will be encrypted and protected regardless of the fact that server-side encryption is being used on the infrastructure side or not. Also, the cloud provider, that is AWS, or anyone with access to the underlying disk volumes will only see ciphered or encrypted data. The data is effectively useless to them unless, of course, they have permissions or access to the encryption keys. What about the drawbacks? The code will have additional complexity of using SDKs and libraries required to perform cryptographic functions. There is always the potential of this additional functionality being inadvertently omitted from the code. What about server-side encryption? For most use cases, server-side encryption can be completely transparent to the developer or application code. Also, from an implementation perspective, it is simpler and easier to use. Oftentimes, it's simply a flag that's enabled when provisioning infrastructure. Now, anyone with elevated permissions to the cloud infrastructure service that's being used, such as admin users, may be able to see the plaintext data. This can be solved by ensuring that role and responsibility segmentation aligns to access permissions on encryption keys. As a best practice, it is highly advisable to leverage server-side encryption as a default deployment pattern for any AWS services being used to store data. The decision to use client-side encryption in your applications may be made on a case-by-case basis for sensitive data or to meet compliance requirements.